Now that you know a little bit about control charts, let's take a look at the 8 tests or rules that we have for interpreting control charts. Remember that a control chart is based on the attributes of a normal distribution. And a control chart basically is taking normal distribution, turning it on its side, drawing a line where the average performance is, and then we create these zones. Based on the 68, 95, 99.7 rule of a normal distribution, we know approximately how much data should fall into each of those 6 zones. So then when you draw your data on a graph, we can figure out whether the data falls into those zones like it should if it was common cause or random data only, or if it doesn't, that's an indication of something special happening to cause the pattern to be non-random. When you look at a control chart, the control limits that you learned were calculated as plus or minus 3 standard deviations from the average will tell you how much variation to expect from your process. The center line will tell you your average performance, and the dots themselves will tell you your real-time performance. This whole shooting match together tells you whether the process is stable or not stable. And remember from the training that stable means common cause variation only is present. If special causes of variation are present, your process is said to be unstable or out of control. Walter Shewhart created control charts in 1924 and came up with these rules, which are called the Western Electric Rules. Those were used for about 60 years until a statistician named Lloyd Nelson updated them in 1984 to improve the control charts by lowering the chance of a false reading. SigmaXL uses these Nelson rules as the tests. Let's take a look at them. Test number 1 is this. Any point that's outside these control limits is considered special cause variation. If that shows up, your process is out of control or unstable. Remember that 99.73% of your data should fall within these lines. In other words, there's roughly a 0.25% chance of a dot falling outside the line. You need 400 dots on a chart like this before you expect to see a dot outside the line. You're not going to have 400 dots. You might have 30, 50, or even 100. So if we see one of these, we know something special has caused that. I liken this to an aerial view of a prison yard, and the dots are the prisoners, and the control limits are the electric fence. Now, if a prisoner wants to walk up to the fence and put his face up there and look outside and see what he's missing, we're fine with that. We don't care. But if we see that one of these little prisoners is outside the line, and I don't care if they're barely outside the line or 1.5 miles outside the line, statistically something has gone wrong, we're calling 911. That's test 1. Test 2 has a nickname. It is called a shift. 9 points or more in a row on the same side of the center line. Remember, one of the properties of a normal distribution is symmetry. Half the data is above the line and half the data is below the line. So literally there is a 50% chance that the next dot you see on this chart would be under the center line, a 50% chance it would be above the center line. So if you go for 9 dots in a row and they're all on the same side of the center line, that's akin to you flipping a coin 9 times and getting heads every time. That's just not random. It's not going to happen. Something special has caused that, and that's called a shift. Test 3 is called a trend. 6 or more points in a row, continually increasing or decreasing, it doesn't matter which side of the center line they're on, is called a trend. Something special has caused that. Test number 4 also has a nickname. It is called a sawtooth pattern. If you have 14 or more points in a row that are alternating up and down, that's equivalent to you flipping a coin 14 times and getting the following pattern. Heads, tails, heads, tails. It's just not random. Often this is indicative of some form of sampling problem. Test 5 does not have a nickname, but if you remember the odds of data falling into each of these zones, there's only about a 2 to 3% chance of any dot falling into zone A. So in other words, if we had 100 dots on this chart, we would expect 2 to 3 dots to fall in there. But if you go for 3 points in a row and 2 of those 3 points are in zone A or beyond, something special has caused that. and the process again would be unstable. Test 6 works on the same basic logic. 4 out of 5 points in the same zone B or beyond. What we know about this would be that roughly 4 points out of 25 should randomly fall into zone B or beyond on one side or the other. If you go for 5 points in a row and 4 out of those 5 points are in that area, something special has caused that. Test 7 has a nickname and also gets a little happy face next to it. It's called hugging the center line. 15 or more points in a row in Zone C. We know that 68% of our data, or roughly 7 out of 10 data points, should be in Zone C. If 15 in a row are in Zone C, something special caused that. The variation has been reduced. The process has been squished. Very often your project will flag Test 7. Test 8 is the opposite. 8 points in a row outside of Zone C. We would expect 7 out of 10 data points in Zone C. If you go for 8 in a row and nothing is landing in Zone C, something special is causing that, and we need to figure out what that is. It might be rounding errors as you measure things. Some people are rounding up, others are rounding down, and that's what's keeping it from being in that range. At this point, if you have a headache or you're confused, don't feel bad. It's a lot to keep track of. Fortunately for us, in SigmaXL, they keep track of all these 8 tests. All we have to do is turn on the alarm system, and that's actually very simple to do. We just go to Control Charts. We'll select at the very bottom, Test for Special Causes Defaults. We make sure to select Run All Tests. You've now armed the alarm system. You save, and every control chart you create now will automatically run these tests for you. When you run a control chart in SigmaXL, it not only will draw the control chart for you, but it will put a red number 1 through 8 next to the pieces of data where these tests have been violated. That will tell you where the test was violated and which test was violated. Now, if you don't remember the 8 tests, don't worry. At the very bottom, it's going to remind you what each of the 8 tests were and also show you exactly where in your spreadsheet those pieces of data are so that you can go study them. Interpreting these is very simple. All you have to do is look for red numbers. If you see any red numbers, it means the process is unstable. The lack of red numbers means this process is stable or in control. It's as simple as that. As we mentioned in the class, there are different types of control charts for different types of data and sampling situations. Now, if you don't remember all of those, not to fear. SigmaXL has built into it an assistant that will ask you some questions. Based on how you answer those questions, it will automatically drop you down to the correct control chart. So you've got a lot of things going for you. The software will not only help error-proof making sure that you select the right chart, but it also helps by reminding you of how to interpret the chart once you've run it. In the next video, we're going to fire up the software and we're going to play around with these.